Many of us don't appreciate the extent to which our everyday lives are dependent upon chemical engineering. We visited the University of Manchester in the heart of the industrial north to learn more about their unique mission and their commitment to translating research into real-world solutions.
Never has there been a greater need for innovation. And here at the University of Manchester Department of Chemical Engineering is where it's happening. They're working to solve some of the world's biggest problems, researching new sustainable energy solutions and methods to produce a net zero carbon future.
Pretty much everything around us at some point had chemical engineering involved. So the way we live our economy is, to a significant extent, is a product of chemical engineering. Then it becomes a very substantial challenge how we can move on to somehow reduce the footprint of all these chemical technologies. But it is a very, very challenging task.
Dr. James Winterburn is one of the academics leading the way.
We're looking at ways of finding alternatives to petrochemicals. So rather than using crude oil as the raw material, as the starting point, we're looking at using fermentation processes, so natural processes that we use to make things like beer or leavened bread. What's really exciting for me is then how we translate that, so move it out of the lab and actually move it towards being a commercial proposition, and so you have a real impact on people's lives then.
To help achieve that, Dr. Winterburn has co-founded the company Holifirm.
What Holifirm is doing, their driving mission is bringing kind of biosurfactants to market, so we can use those to replace petrochemical surfactants. And surfactants are the ingredient that are in all our cleaning and personal care products. They give cleaning action, so we all use surfactants every day.
The company's cutting-edge work has recently secured £7 million of funding.
And that's actually allowing us to scale up our technology from pilot scale to what we call a commercial demonstration. So we're going to be building a plant that will produce 1,100 tonnes per year of these biosurfactants, so we can really start bringing them into the market.
Professor Aileen Miller has formed her own company too, Manchester Biogel. It's born out of her passion to produce animal-free technologies, which are now being used in the pharmaceutical sector.
For me, it was really important to have an impact with my own research. If you think about the pharmaceutical sector as just one sector and the testing of new drug entities, about 3 million animal procedures are done in the UK alone. So replacing those types of studies is going to have a phenomenal impact on the environment, our society, but also it's going to give more reproducible and reliable data, because we're going to use human cells in synthetic materials to really get an indicative answer of human behaviour and human responses to drugs, whereas you don't get the same kind of correlation when you use animals.
The passion of everyone at Manchester Chemical Engineering is to ensure that their pioneering work gets out of the lab and into production.
Spinning out your own company is one way to generate sort of commercial impact. The other way is to work with existing businesses. If you work with a large corporate that has got huge resource behind them, then that can really expedite the translation of your research.
It's that mix of ambition and collaboration with business that's attracting the next generation of chemical engineers.
I'm also a chemical engineer who happens to be a classical chemical engineer, which is really looking into things that were developed 100 years back, 150 years back, but then using many of the modern improvements that we have in terms of computation, in terms of, let's say, sophisticated tools that we as society have developed from other fields like computer science, imaging. I'm trying to make those existing processes more sustainable, more efficient, more carbon friendly or climate friendly or friendly to the planet. The thing that drives me is to make sure that I leave a sustainable world.
The University of Manchester is the 19th century birthplace of chemical engineering, a place where expertise and innovation go hand in hand. But our future has never depended so much on that expertise and innovation.
Chemical engineering is responsible for the quality of living that we currently have. But we also need to remember that all these things that we do, our quality of life, also comes with a cost. And that cost comes in the form of energy demand, greenhouse emissions, plastics, things that become unrecyclable waste. And if I look at all these challenges, I still believe that chemical engineers, as sometimes creators of these challenges, are also best placed to address them.